Hello everyone. This is one more interesting question that is related with the igneous geology, and this kind of questions are generally asked in GATE and in CSI-NET exam. So, how to approach this question in the exam, and what are the things I'm going to tell you in this video is first we will understand that what is batch melting and what is relay fractionation model. Okay, these are the two models that we are using. Okay, so we will understand which one is using in our case. Okay, also, and apart from that, whatever the terminology we will see in the question, we will try to understand that one also. Okay, so we will try to understand this question in detail. Okay, with respect to this question, I'm going to explain this question. Okay, and if you have any other query, or apart from this question, if you have any other question that you want to discuss with me, I'm ready to discuss with you. Okay, so be ready for the opportunity. Don't waste your time. Okay, opportunity will come and go, so be ready. Okay, and ask question from the system from wherever you are learning. Okay, that is very important. Okay, and share this video with your friends also, so that they can also get benefits. So let's start our question. In this question, they are asking about what? A rock contains 60% olivine. Okay, 60% is olivine and 30% is clinopyroxene, and 10% is pyroxene by weight. Okay, and has 150 ppm of trace element X. Okay, what would be the concentration of X in the melt after 10% equilibrium melting? Okay, now first we will understand what this question is telling to us. Okay, we will understand that one. Okay, I will go in batch melting and other things. Okay, first term we will understand that what is trace element. Trace elements are those elements whose concentration, okay, whose base percent is less than 0.1%. Okay, by weight. This is the condition for trace element, means they are very rare. Okay, so now, and if something is less, and it is means it helps us to understand the nature of the magma and other things. From trace element we are understanding. Okay, what are the trace element that we are using? We are, we have already discussed 2-3 questions. Okay, rubidium, strontium, okay, SM and D. Okay, so now next thing is trace elements are less than 0.1% by weight. Okay, so now we have a rock. We are having a rock. Suppose this is our rock, in which we are having olivine. How much? 60%. Suppose this is half and this is our 60%. 60% we are having olivine by weight. Okay, not by volume. Okay, by weight only I'm talking. Okay, by weight only. Okay, and 30% we are having CPX, and 10% we are having OPX. Okay, and in total, in whole rock, okay, in whole rock we are, this is a whole rock now. In whole rock we are having how much? X is the trace element. X is the trace element whose value is 150 ppm. Okay, in the whole rock. Okay, now some value of this is present in olivine, some value of this is present in OPX, and some in CPX also. They are giving in this form. The given mineral melt distribution coefficient of X for olivine, clino means coefficient of X, okay, for olivine. For olivine it is 0.06, 0.0006, and for CPX it is 0.09, and for for OPX it is 0.09, and for CPX it is 0.02. Okay, this is our 60%. Okay, I'm converting that 60% into point. Okay, so we will get 0.06, 0.03, and here 0.1. Okay, 10 means 60 by 100 na, so we will get 0.6. Okay, and converting that percentage into, okay, this. So now, and one more thing is that if I will ask you one question. Okay, you just mention in the comment box. Okay, a rock contains 60% olivine. In a rock we have a 60% olivine, 30% CPX, and 10%. What is the rock name? Olivine is 60%. It means it is ultramafic rock. Okay, so what is the rock name? Mention in the comment box. Okay, what is a rock name? %60 olivine, 30% CPX, 10% OPX. Okay, it is ultramafic rock. Which one? Okay, this is the question for you. Now coming back to the things that we are understanding. So now this rock, okay, now this means this 150 ppm is distributed in this way. Okay, in the whole rock. Now this rock is now melted. Okay, this rock is now melted, and we are getting a new liquid. Okay, how much it is melted? It is melted up to 10%, means 0.1. Okay, now if we melt this rock that is having this all those minerals, and this X value is 150 ppm. I will change the color. Okay, now this 150 ppm value that is present within the whole rock of X element is now going to increase or decrease in this. It is going to increase or decrease. If you think in that way, total we have 150, and we are melting this one, you think it will decrease because total is 150. No, don't go with this way. Okay, okay, because we are melting this rock only 0.1%. Okay, and these trace elements are the incompatible elements. Okay, they prefer liquid instead of solid. They will come first from the solid. Okay, while we will melt this part. Okay, so now we are melting this, okay, 10%, and maintain equilibrium. Unless this melt has not reached up to 10%, we are there. Okay, means material is there itself. Okay, with the rock. Okay, so after 10% reach, it will come out, that the magma that are forming will come out. Okay, so now in that magma, what is the percentage, what is the value of X in that magma? We have to calculate that one. Okay, one thing we have to understand, that in each we are having some value. Okay, suppose this value is, suppose we have some weight of this rock. Now from the melt we are getting 10% melt, and again we have some this weight. Okay, so this weight having, suppose we have a 1 kg of, for better understanding, okay, I'm going to do this 1 kg of this rock. Okay, and we are getting 150 ppm. Okay, now I melt this. Okay, 10% means means I will take 100 kg. Okay, 10 kg. Okay, so that we can calculate. So now for 1 kg, for 1 kg, don't go with this one divided by 10. Okay, this ppm, no, this is the wrong way. Okay, this is not that question is asking, means telling this. Okay, this question is means the system is telling us that we are melting the rock up to 10%. Now we have to calculate that one. I'm telling you that why this value is going increase. In our mind it will come decrease, but this is the right way. Its value is getting increase. We are not getting value less than 150 ppm in this case. Okay, why values are getting increase in the later magma? That thing we have to understand, because these trace elements are incompatible elements, and this rock is ultramafic in nature. From ultramafic nature, if we differentiate something, we will get a silica rich part. From ultramafic to mafic to intermediate to felsic or stick. In this way we are going. So our trace elements concentration means the incompatible elements are getting increased in the later phase. Okay, so its value is getting increased instead of decrease, but volume is getting reduced. Initially it is because volume is more. This much volume we have, suppose. Now we are melting up to this much only. Initial trace elements are like this. After melting of this trace, okay, so these trace elements will come out of this, because trace element will come first, na? Here it is 150 ppm in the whole rock. Okay, in the whole rock. Now its value is getting increased because volume or weight is less now. Okay, how much it is increasing? We will use the formulas for that and we will calculate that. Hope you understand that why it is getting increased. Okay, main purpose is that by putting formula and getting the answer is not the main thing that I'm trying to tell you. Okay, why this is happening, I'm telling you that thing. Okay, so now up to this you understand. Now we will go further. Okay, now which method is using in this? Okay, which method is using in this, batch melting or that fractional model, relay fractionation model? Okay, so we will understand the difference between the two. One is batch melting model versus relay fractionation model. From the word itself you understand this first. Fractionation, relay fractionation. Fractionation means differentiation. Fractionation means differentiation. Suppose this is our magma chamber. Okay, due to gravity settling, there are some methods in the differentiation, fractional crystallization. Some minerals are formed. Okay, this is our magma. Okay, initial magma. Okay, now we are getting some crystal that is formed at the base due to gravity settling or other thing. Okay, so this is our liquid now. Okay, now this liquid is coming out from the system, or it is not reacting with the system. Okay, only we are getting liquid now. Suppose again this is happening, we are getting some minerals here and liquid here. This newly formed will not react with this, and this liquid will separate out again. Okay, its volume is getting reduced. Okay, again mineral. So in relay fractionation, the mineral that is forming will not react with the system. If mineral is not reacting with the system, we use this method, relay fractionation method. We use relay fractionation method in that case. Okay. Okay, and these are the isolated systems. Okay, and in this way, now in this case we are using this relay fractionation method. Now for what purpose we are, what are the condition for batch melting model? For why batch melting model, here minerals are reacting with the minerals are now reacting with the system, na? The liquid, but in this case equilibrium will come, equilibrium melting will come. Okay, equilibrium melting case will come or process. Okay, this means we have a rock, we are now partial melting of this rock. Okay, up to how much it is going to okay, 10%, 20%, 30%, but to but we are not separating the magma from the rock. Okay, we have to, because in nature, due to differentiation, if we have a small container of magma, differentiation will take place. Okay, but we are putting some condition like that, we have a 10% equilibrium melting. Okay, till 10% equilibrium melting we are not having any differentiation. Okay, our magma and that source rock, from that where it is coming. Okay, and magma is creating in this system. Okay, suppose this is our magma in this case. Okay, suppose some crystals is forming here. Okay, this, okay, this crystal will react with the liquid. This crystal will the means the suppose this magma is now crystallizing, this magma will react with this. Okay, okay, from the initial rock. Okay, so now okay, this is our melt, we are getting solid plus liquid in it. Okay, and this process is going on. Okay, so this is the main difference. Batch melting model we use in the equilibrium process. Our melt and the melt that we are created means from the rock that is created, and after that melt is created, the minerals that are growing in it, it will react with the liquid. Okay, and that equilibrium is maintained. Okay, until that rock is not crystallized whole. Okay, the minerals keep on reacting. Okay, this thing happen only when this thing happen only when rock is silica rich. When rock is silica rich. Okay, I mean later stages of the differentiation. Okay, from ultramafic to granites we are going. Granites are rich in silica rich rocks. Means for in example. Okay, I'm talking. Okay, so in, because if we have ultramafic rock, the mineral that form will not react with the system due to differentiation. Okay, so hope you understand the difference between the B batch melting model and relay fractionation model. Okay, if you want more detail on this, because there is so much information in these two things also. Okay, that's why they are asking these questions. Okay, and this is not that easy concept. Okay, okay, once you understand now why magma the value is getting increase and value is getting decrease in a system, then you will understand this and what are compatible incompatible elements. So if you want video on that, just mention in the comment box. Okay, I will try to make video on that one from the basic if you need. Okay, basic point of view. Okay, so now in the question they are asking means given that 10% batch melting, so we will solve this question by batch melting model. because equilibrium is maintained in batch melting model. Okay, here it is not maintaining. Okay, because the minerals that are forming will come out of the system. Okay, and the liquid will again differentiated and the new minerals and this in isolated system. Okay, separate isolated system will form. Okay, so hope this much you have clear. So I will remove this part and we will try to solve our question. So apart from question related to batch melting come so many times, already come so many times, but with respect to relay metal it is not coming yet. Okay, so chances of getting with that also is higher now. So we will solve this question. Okay, so to now we are having our this olivine, and in which in olivine we are having this much mineral distribution coefficient. Okay, so we will calculate bulk distribution coefficient. Okay, bulk distribution coefficient means summation of what? Summation of all these weight percentage. Summation of all these weight percentage of minerals. Okay, with distribution coefficient. This is our distribution coefficients of x, distribution coefficient of x in minerals. Suppose I am writing here, what I will write, suppose a here also. Okay, for x we are calculating. Okay, so what it mean now, and what is W is the weight fraction of the mineral. A means olivine, OPX, CPX. Okay, and this DI is 0.6. Means what are the values given into us? 0.06, 0.09, 0.02. We know that olivine is 0.0, 0.6. This is 0.3. This is 0.1. So what we will do? We will multiply these two values. Okay. So what we will get? 0.6 into 0.6 into 0.006 plus next one is OPX. OPX is 0.3. 0.3 into 0.09 plus we have 0.01 and we will multiply it with 0.02. Okay, so now if we multiply means 6 are 36. Okay, and we are having how many zeros? Point at what point place point will come? 1 2 3 and as for 1 2. Okay, this is our next one is 3 9 ja 27. 27. Okay, 1 2 3. 2 1 ja 2. What will come at? Number 0 will come. And if we add all these values, we'll get 3 6. Okay, 6 6 2 3 0.0. This is the value we are getting. Okay, for bulk distribution coefficient. Okay, for bulk partition coefficient. Okay, so now we will use this value in our batch melting formula. Okay, this value is our, I will remove this part. Up to this, hope you understand. Now main thing is why we are doing this. Okay, if you understand this those things now, then you will remember for long. Okay, so we are getting our value for this bulk distribution coefficient, and our value is 0.0326. Okay, our batch melting formula. Okay, now we will directly put our all the values in the batch melting formula, and our formula is Cl upon Co. Okay, I will explain this formula also. Is equal to 1 upon d plus f1 minus d. This is our formula. Okay, so Cl means concentration in liquid, concentration in liquid, concentration in original. Okay, CO is concentration in liquid, original. In original, how much x, value of x is 150. So we are having this value. Okay, this value we have to calculate because we have to find out the concentration in the liquid also. What now? So now we'll and this value of f from where? From this. Okay, from this 10%. Okay, 10% means 0.1. Okay, so we will put all the values and try to. Okay, I will use this. Okay, 150. Okay, for this value I'm just putting here. Okay, cross multiplication. Okay, d is d, just we calculate. Okay, distribution is 0.0326 plus 0.10, this one. Okay, 0.1. Okay, I'm writing 0 also, that you will not get confused. Okay, into 1 minus d, this number 0.0326. Okay, what we will get? What we will get? We have to just simplify this. Okay, and we will get, after we will subtract this to 150 is there. Okay, first we will subtract this number. Okay, what we will get? 0.1 into this number, we will get 1 minus is 0.9674. And if we multiply this number with this, okay, later we will do that. Next is we have to add this number with this. Okay, now 150, if we multiply this number with 0.1, what we will get? We will get 0.09, because 1.1 more point will 0 will add. Okay, 9674. Okay, and this side we have to add 0.0326. After adding this value, these two values, what we will get? We will get 150 divided by 0.1 to 934. After adding the values. Okay, and after dividing these two values, we will get 1159.6 ppm. Okay, and we will get approximately 1160 ppm. So in this way we will calculate our. Now in the original rock we are having 150 ppm, and we are getting now how much? 1100 ppm, 1160 ppm. Okay, so our answer is this one. So now hope you understand in which way we are calculating this. Okay, and if you have still any query, you can ask me. If you want any detailed thing from me, I will add those things also. Okay, hope you learned something from this video. Share this video with your friends so that they can also get benefits. Okay, and try to answer this question, okay, that I have mentioned. Okay, what is the rock name? Okay, because this question already came na, that's why I put. Okay, and chances of coming not in GATE or in CSI, in other exam also you will see this question. Okay, okay, thank you, hope you learned something from this video.